Hello everyone, my name is Joshua and I'll be solving repeated string from HackerRank's interview prep questions. Here's a problem. Many of you have already liked and subscribed, but there's a number of you who haven't, so please subscribe. It's easy as 1, 2, and 3. And you can also support my channel with some of the links down below. There's a string of S with lowercase English letters that is repeated infinitely many times. Now given an integer of n, you want to print the number of letter A's in the first n letters of that infinite string. So for example, we have an S and an N as inputs, and this S is repeated infinite amount of times. That's why we want to constrain it to this limit of number of characters we want to examine within that range from 0 to this 10th character. And we want to find the number of occurrences. In this one, it's going to be 4 A's. There's another example right here. As a matter of fact, I have a diagram. Let's actually dive into the problem. So some people might be thinking, okay, to solve it, maybe I should just take that string, create a new string, and then add whatever remainder it is to make sure it makes that limit of n equals 10. And there you go. Now I created that string. I could go do a for loop right again. Count the number of letter A's that occurs. 1, 2, 3, 4, 5, 6, 7. And ta-da! There you go. You get 7. Oh, it works. Well, that's a good idea, but if you're doing an interview or you're doing a class test on this kind of stuff, they might ask you like, okay, this is you did the preschool style, but can you do it the collegiate or industrial way? What do I mean by that? Now, there are ways that you can improve this. You can see like, okay, right here it takes about k times n. Oh, not k times n. Holy cow! I totally screwed that one up. But it's going to take about n space to create a new string, because we're creating a new string from the old string. Just to store that value, it's basically a data structure in itself. And then we're going to iterate through it again n times. So can this be reduced? And if so, how? Now you can see a pattern right here. When it repeated multiple times, you can see that I don't really need to create a new string repeated multiple times. All I really need to do is count the number of occurrences within that string, multiplied by how many times it's necessary, and then I could go over that same string again and just count like, okay, there's still a margin we have to account of, and that is that one more extra value. In this case, it's just going to be letter A. So it'll be a total of 2 times 3, which is 6, plus the extra time that I go over it one more time for the extra margin, that would be 7. And you can see right here the value, it still has that same result, and the time and space performance is much more better. So in the case of time, I really had to go through O of k times, just go through that substring. Okay, that's the number of letters within the string. What does this n modulus k mean? Well, n modulus k means the remainder of, let's just say if 10 is less than k. Oh, actually, this is going to be n divided by k. Now let me explain why. So if it's n modulus of k, that means that it's the remainder of, let's just say, if I do this again, right here, if I show you what n modulus k looks like, if I want to do 3 divided by 10, I could see right here that it takes 3 3s to make up 9, but I can't do another 3 because that'll be 12. The remainder that's left is 1. That's how moduluses work. It's the remainder of how many times one value can go into another, subtract that off, and that's what you're left. So you can see here that time and space complexity is quite different. The time complexity really depends on if the k representing the number of letters within that string is less than n, or if k is equal to n, or n is less than k. It's going to be better than n itself, because if n is less than k, then that means it's really just going to be n modulus k. I mean, k divided by n or n divided by, it's going to be n. If n is less than k, it's going to be n modulus of k. And if n is greater than k, then we really just need to go over the small parts right here. We don't have to repeat it multiple times. And the space, we're not creating a new string, so that's pretty good. We save some space right there as well. I think it's better if I show you through the problem itself. If I did this impromptu, I probably could have explained it much more better. Sorry about that. Okay, so let's go ahead. So first, we definitely want to find a number of A's within the string. We initialize it to A equals 0, and we want to return A at the end of this problem. The first thing we want to do is go through each letter. So I do a for loop to iterate through each letter, const letter of string. For each letter of the string, I just want to check if that letter is equal to A. And if it's an A, I increment by 1. There you go. And once that's done, we literally multiply the number of A's by that value I showed you in that diagram right here, n divided by s dot length. I think it's better if I show you right here that k is equal to const. K is equal to s dot length, and then it'll be much more easier to represent in the diagram. You can go ahead and rewind to see if it matches the diagram in that way, and divide by k. Now, since that value will be a whole number, we can multiply by fraction numbers. In case that occurs, I'm going to use math.floor so it rounds down. And now we want to go through the remainder of letters in case there's still more we have to go through. It doesn't perfectly fit. Like if you multiply it that amount of times, there's still that remainder we had to count of, the margin. Then I do let index is equal to 0. Index is less than k, n modulus of k. And I showed you what that modulus meant. And this, where I got the n modulus of k, again, it's for this part right here, n modulus of k right here. And then I go through it one at a time. And if the letter that index is equal to a, then a plus plus. Now this would be passing, but there's something else I have to consider as well. So remember the conditions, the scenarios that can occur. K can be less than n, k can be equal to n, or k can be greater than n. In the case that where k is greater than n, you don't really need to solve this part right here, because if we do, we're kind of doing twice the work in a way. We cut the number of letters in a whole string of s, which you really don't need. Just need the first n letters of the k. And when we do math.floor, if n is less than k, that's going to be equal to 0. And basically we did all this work for nothing. So to make it much more nicer, I'll just do it this way. If n is, we only do this work if n is greater than or equal to k. Let's see if that's the correct answer.
Hey, that's pretty good.
Passed. Nice. Now I hit submit. Great. Alright guys, I hope this makes sense. I hope my diagram makes sense, the benefits. As you can see, this one creates a new string of O of n, and the time you go iterate is O of n. But here, there's a chance where it could be less than O of n itself when going through the for loop. And also the space, you're not creating a new string, so therefore you're in constant space. Alright guys, I hope this helps you with tests. Please like and subscribe, or help me and support me in my channel via the links and descriptions down below. Until next time, to infinity and beyond.